Here we're given two equations and asked to solve the equations for a particular variable. Our first equation, we have b equals h divided by a, and we're asked to solve the equation for a. Notice in this case, we're trying to solve for a, but a is in the denominator, so we're not going to be able to solve for a until we eliminate this fraction. We can eliminate the fraction by multiplying both sides of the equation by the denominator of a. So we'll multiply the left side by a, as well as the right side by a, but on the right side, let's write a as a over 1. So notice now on the left side we have a times b, or ab, and on the right side, notice how when we multiply these fractions, there's a common factor of a over a simplifies to 1, so we have just h on the right side. Now remember, our goal here is to solve for a. ab means a times b, so to undo this multiplication and isolate a, we can now divide both sides by b. b divided by b simplifies to 1, so we have a equals h divided by b. As another option, starting with the equation b equals h divided by a, we could write b as a fraction, meaning b over 1. Now that we have a proportion, we could cross multiply and then solve for a. Notice if we cross multiplied, we'd have a times b must equal 1 times h. Well, a times b is just ab, and 1 times h is equal to h. Notice how we have the same equation here as we did here on the left. If we divided both sides of the equation by b, notice how we would still have a equals h divided by b. So there's more than one way to solve this equation for a. Next we have the equation ax squared minus bx minus c equals 0. We want to solve this equation for a. Notice a is here, the coefficient of x squared. So our first step is to isolate the ax squared term. So we don't want this minus bx and minus c on the left side with the ax squared term. So to undo this subtraction, we'll add these terms to both sides of the equation. Let's go ahead and do this in one step. Let's add bx to both sides, as well as add c to both sides at the same time. Notice now on the left side, negative bx plus bx is 0, and negative c plus c is 0. So we have ax squared equals, on the right side, bx plus c. And again, our goal here is to isolate a. Ax squared means a times x squared. So to undo this multiplication and isolate a, we'll divide both sides by x squared. Notice here on the left side, x squared divided by x squared is 1. So we have a equals the quantity bx plus c divided by x squared. So our equation solved for a is a equals bx plus c divided by x squared. So this is fine as our answer, but I do want to show how we could express this a little bit differently. We could write this as two separate fractions and write bx divided by x squared plus c divided by x squared. If we did this, notice how we do have a common factor of x here. This x would simplify to 1, and the x squared would simplify to x to the first, since we have a common factor of x. So we could also express a as a equals b divided by x plus c divided by x squared. Either of these two equations solve for a are correct. I hope you found this helpful.